All right, y'all, so what I'm going to try and do with you on this video is explain how we're going to use Newton's second law to solve these kinematics problems. In kinematics, I usually just gave you the acceleration and said, hey, Earth's gravity is doing this, or a rocket motor is doing this, causing this thing to have an acceleration of 3 or 9.8 or whatever. What we're going to do with this unit is look at how to look at all the forces that are acting on something, distill them down into the net or the unbalanced force, and then get our acceleration that's going to go here and here. Those aren't zeros, those are me circling the thing. And we're actually going to do this in 2 dimensions, and so really what we're going to have is the net force. I'm not sure why that had to come with. We'll have the net force in the x direction causing the x acceleration, and the net force in the y direction causing the y acceleration, right? So we're going to be using Newton's second laws to find this, and then we're doing kinematics again. So the tricky part on this is that oftentimes these forces are all going to be going at different angles to each other. You know, and in this situation right here, you might have someone pulling up into the right and someone down into the right. And what we need to do is figure out a way to say, yes, I've got things happening left and right at the same time, but I still need to figure out what is the net force acting on this thing. Well, one easy kind of conceptual way we can do this is what's known as the tip-to-tail method. And the idea is you just draw faithful graphic representations of all 3 of these vector arrows from the tail of one to the tip of the next. So we'll start with A, and it looks like A goes over 4 and up 2. And so here goes. A goes over 4 and up 2. Sweet. And then continuing from there, we'll look at B. B goes over 2 and down 1, so something like that. Last but not least, we got C, and C just goes back 2, so it looks something like that. So if you draw a vector from where you started to where this thing adds up, this right here is going to be the sum. This is going to be the net force acting on this object, and it looks like it goes over 4 units and up 1 unit. I want to make it very clear that it does not matter what order you go in when you do this. I want A, then B, then C. We could go the other way too. Let's start with C this time, and it looks like C goes to the left, and then B goes to the right and down 1. So there's C, there's B, and A goes up over 4 and up 2 like this. So the net force acting on this is going to be that vector right there, which again goes over 4 and up 1. This is a great way to conceptually see what's going on. If you really needed to have some specific numbers, then great. You can draw this out to scale, draw this, measure it, get a compass to see the angle and the length of the resultant and everything. All right, so let's try another one on here. See if y'all can get this one right. We're going to start from here. I'm going to go up 1. That's this boy right there. And this next one goes over 1. Check. That's this boy. I think I'm going to need some more room here, aren't I? So let's come over here and draw it this way. This third vector right here, it looks like it goes down 2 and to the left 1. Well, if I was smart about this, I would have snapped this right. Boom. We're going to go down 2 and like so, and oops, that was that one. And this last one goes down 3 and over 1, so something like this. All right, this vector has a resultant. Oops, I want to switch back to my other color. This vector has a resultant that looks something like this. It looks like it's going to the left 2 and down 3. So what I'm going to ask you all to do on this concept builder, oops, I don't show you the answers yet. This first little concept builder is just known as the vector addition tip to tail. I'm going to ask you guys just to get the apprentice level trophy on this, where they're going to give you, gosh, what did this be, 42 different combinations of vectors, and they're going to say just add them up. Right? What are you going to get when you add these 3 together? So W, let's see, starts right here, and if I add L to it, well, it looks like L goes down 2 and to the left 1, looks like that. And then I'm going to add C, and C goes up 1 and to the left like that. So my resultant vector is going to be down 2 and to the right 1. That looks like that's going to be J. So I think my answer is going to be J on this one. Let's find out. Vector addition, I think I'm going to set J and check the answer, and woohoo, I got it right. Okay, so that's all fine and dandy. We can do this very, very conceptually, and I can say things like to the left or up and to the right or something like that. But what would be helpful is if we actually had a more specific way of describing this, right? Rather than saying this thing goes to the left and down, which if you really wanted to be fancy, I don't know why I just used a V there, you could say that this net force is minus 2 I hat minus 3 J hat. If you want to use unit vector notation, you totally can. I actually like that. Instead, though, you all have been used to doing polar coordinate stuff in math. So you're going to say something like, oh, it is at an angle of blank, or it's this angle above the horizontal. And there's two ways that we're going to describe a vector. So let me draw this one up again that goes over 2 and down 3. There's two ways that we can describe the direction of this vector right there. In terms of angles, we could describe it like I just did with unit vectors, or we could say the angle that it makes. Now, typically, in your math class, you've learned to do counterclockwise from the east, right? This is 0, this is 90, this is 180, and this is 270. Pretend I did 270 and not 207. In geometry, they would say we're going to measure this angle right there. Well, you could set up some inverse trig on this triangle that this thing makes, like so, to solve for this angle and then add it to just 180. That's fine. Sometimes what's going to be more useful for us in physics, though, is not to describe counterclockwise from the east, but we're just going to describe, above or below the horizontal, or we might say something like right or left of vertical. In this particular case, what I might do is instead of describing that angle, I would just say something like, well, it's going to be this many degrees below the x-axis to the left. Or I could say it's this many degrees below the x-axis in, what's this, quadrant 3, right? Because there's 2, there's 1, and there's 4. And this is so simple. I mean, it's almost insulting to ask you to do this on this concept builder, but I'm going to ask you to convert back and forth between counterclockwise from the east, your typical math, like measure all the way around from 0 degrees, to more of a relative reference angle. And so this next one, we are going to convert 74 degrees north of west into counterclockwise from east convention. All right, so north of west, 74 degrees is coming up like this. That's a 74-degree angle because here's west, east, north, and south. And it's going to be 74 degrees above the x-axis. Well, y'all, hopefully this is just insulting right here. I'm asking you for this part, which is, of course, just going to be 100. That is an 8? Really? Okay, let's try this again. It's just going to be 180 degrees minus that angle in there, which I believe is 106 degrees. Let's find out if I'm right. Vector direction, tab. Okay, you don't want to let me do that? I'll just type my keyboard. Are you serious right now? Oh, I guess you have to use the built-in number pad. Check answer, and correct. Yeah, we got it. Fantastic. I'm going to save this next part for in-person with you all today, or on Tuesday rather. There's a third concept builder on how to actually find the magnitude and the resultant and everything. I'm running low on battery and I'm going to save it for next time. So what I would love you all to do before you come into my class tomorrow, knock out the vector direction one right here and knock out the the vector addition. That's the first two. Don't worry about the component addition yet. That's going to be this one. We're going to do this together in class on next time I see you. All right.